Hello, my dear warriors. Vanakkam, welcome. Sat Shri Akal, Marabba, Ola Bonjour. Welcome aboard to We Enlite, the dedicated English medium channel for all the JEE and NEET aspirants. And we are already on lecture number 2. And we have kick-started the legend series for all the 11th standard students who are going to become ultra legends next year. But for now, targeting JEE and NEET 2024, all the 11th standard students, welcome aboard. And this is the units and dimensions chapter, and we are on the lecture 2, errors analysis and the least count. And that's me, Shreyas, your physics master teacher. Hello legend Prachi, nice to see legend before your name. And if you are a regular student out here, I would be happy to see the legend word before your name, because the 12th standard students will put ultra legends before their name, so that I know you guys are 11th or in 12th, and everybody else also know that you are legendary students learning from the legendary channel We Enlite. And I hope you have smashed the like button for our legendary channel out there. Hello Ranjit, hello Niharika, hello Naveen, hello Prachi, hello Ritesh. Welcome aboard, guys. And please join the Telegram channel, because that's where I'll be uploading the PDF and you'll be getting updates of the upcoming classes as well. It's also a good time that we also congratulate so many students who have made Vedantu really proud. They are your seniors, and you too will be one of these. In fact, this number will just go higher. Just take a moment to look at their faces who have made you, the entire community, our teachers, our staff, everybody proud. Awesome results in our JEE mains second attempt and the first attempt. 480 students getting about 99 percentile. It is crazy, 2000 plus students about 90 percentile, and so many getting qualified for JEE Advanced. And even perfect scores by so many students. Keeping it up, guys. Very good, very good, very good. Hello Arvind, hello JEE aspirant. Welcome aboard, guys. Let me just bring you guys up on the screen, maybe out here. Hopefully, yes, hello. Ankit, nice to see your new display picture out there. Hello Tharvin Sherry. Hello Jyoti, hello Arjun, hello everyone. Sir, my Instagram account is not appearing, is it? Where, in the link or otherwise? I think it should appear. Just check this out. Yeah, where is it? Where is it? Where is it? It's not here, is it? Oh, my Instagram link is not here. You just need to search for Captain_Shreyas. That's my Instagram link. Yeah, that's something which you should know. Okay, again after 1D. So acing, very good question. Good you asked that. So let me tell you guys, this entire legendary series, right, is a very interesting way of completing the syllabus, because last year I have completed, if you go down in the playlist section, right, 11th standard nurture physics, I have completed all the chapters. So obviously there is no point, and students also said, sir, don't do the same thing, but do something which will add value to these classes, because I have done last year also all these lectures of 11th standard, right, from the beginning till the end. So these will be value added classes. It might not be the complete lectures, obviously, because I expect you to go through these lectures. So these will be value addition lectures for NEET as well as JEE students, and it will also give you a different perspective and also additional problem practice. I will not repeat the same questions which I have done last year. I hope that is clear. Hello Koida, nice to see Bachan, my new students. Wow, nice to see you guys. And some of you are joining in today. And the droppers batch has started, Salva Karthik. Yes, the English medium one as well. Hello Arvind. Welcome guys, and I hope you have smashed the subscribe button. So I have a simple question for you. If you have visited a shopkeeper, or if you have visited a tailor, or if you have visited somebody who measures some certain things, maybe a mass, maybe length, maybe time, you always see that there is a smallest value which you can measure. Because today's topic is all about errors and measurement and least counts. If you have visited a shopkeeper who gives you rice or gives you some, maybe apples or I don't know, some vegetables. So there is, if he's using a digital scale, there is always a least value by which the counter increases. Usually it is 0.1 or 0.2 grams or whatever. And that tells you basically the least measurable value by the device. Anything below that is beyond the capability. It will just be your guess. It is not going to give you accurate results. That is called as the least count of your device. Yes, NEET aspirants, you can watch the nurture series from the previous lecture. Yep. You can still crack it, Ram. You have joined in. At the right time, bacha, there is good 1.5 to 2 years for you guys to crack. Usually, a stopwatch like this or your watch over here usually has a least count of 1 second. You cannot say, sir, I know, when I saw that second hand, it was between that this pointer and this pointer, it is, sir, 2.5 seconds, sir. It was between 2 and 3. No. 2.5 seconds you cannot measure using a normal stopwatch. You need more accurate devices. It's beyond. Same thing with a scale. If you have a scale, can you just lift it up? Can you just pick it up and tell me what is the least count of your regular scale? Hello Vishali. Thank you Deepthi so much. Ram Sukesh, even an average student can crack JEE very easily. You need focus. You need the right guidance. You need the right resources. And you need regular practice. And you need to have that patience, bacha. So you need all these qualities. Even if you are an average student, you can easily crack it. Mark my words. Yep. The least significant value is something which I forgot. Yeah, that's the smallest possible measurable value. So a normal scale has a least measurable value of 1 millimeter. You cannot measure less than 1 millimeter. If somebody says, sir, you know, here is what happened. I took a scale and this was, let's say, 2 centimeters. This was the next thing. This is the next thing. This is next thing. This will be obviously 2.1 centimeters. If your object comes in between over here, what will your length be, guys? What will your length be? Will it be 2 centimeters or 2.1 centimeters? Will it be 2 centimeters or 2.1 centimeters? It will be 2.1 centimeters. No. It will be 2 centimeters. It is not going to be 2.1, guys. No, it is going to be 2 centimeters. All right. Similarly, if let's say for example, this is your scale. Let's say this is 4.1. Let's say this is 4.2 and so on and so forth. And let's say your object lies like this. Then what is the length of the object? Is it 4.1 or is it 4.2? Is it 4.1 or 4.2? It is not going to be 4.2. Even if it is close to 4.2, it is going to be 4.1. This is the rule of measurement. This is what many students make mistakes in. You should know the perfect. This is the way engineers measure. You might be like, sir, I'm not getting that feeling. My heart is not with whatever you're saying, sir. I think it should be 4.2. See, no, sir. It is so close to 4.2. No, you always measure that value which you have passed, you have crossed, not which is closest. You never measure what is closest. You will never say what is closest. It will be just whatever is crossed. So it will be 4.1. It is not 4.19. It is not 4.18. That is just your gut feeling. You might be like, sir, I know it is 4.1. No, that's not how it works. It is whatever value you have crossed. So it will be 4.1. That's it. End of story. Reason is, on the other side also, wherever there will be 0, okay, wherever there will be 0, you would have put 0 over here. And this will be, let's say, 0.1 and so on and so forth. Okay, there will be many numbers in between. So on the other side also, it can lie anywhere between 0 and 0.1. Realize that. Even if it is somewhere here, you will still count it as 0. So both ways you have to follow the same rule, and only then you can measure a device. Not many people know this, and that's the reason why I have given this out here. So guys, coming back, now how do you represent those values? How do you represent those values which you have measured using some instrument? Did you just realize, yeah, Srinath made that mistake. Even I made that mistake. So many students whom I teach make that mistake. Even when I was your age, I made the same mistake. Then I realized, oh my God, this is not the correct way of measuring. That is just what we feel. Something else is there. Okay. So how do you represent the measured value? Because I know every instrument has an error. Is there any instrument in this world which says, no, 0 error, this is the best device? Is there any such mass measuring device? Is there any such length measuring device? Is there any such time measuring device? I don't feel so. And this is very unsatisfying, especially as a school student, especially as a student who has been trained to think in a particular way. Everything is perfect in this world. I can ignore air resistance and I can calculate the trajectory. G value is 9.8 meters per second. I'm pretty sure it will be different at different places. You have been trained to think like that. But that's what engineering is all about. Engineering is accepting faults. Do you guys have faults? Do you guys have some bad habits? Yes. Do I have some bad habits? Maybe yes. Do I have some shortcomings? Definitely. Everybody has shortcomings. Does that mean I don't love you? I love you. Does that mean you don't love me? Obviously you guys love me. Does that mean your friends don't love each other? Obviously you like your friends. Even though there are shortcomings, you accept the way they are. Same way, we engineers will accept that there is always a certain degree of uncertainty. We are okay with that. As long as our system is good, as long as our calculations don't cause an accident, as long as things don't break or fall apart, as long as it doesn't look very untidy. So there is always a tolerance level. There is always some, margin of error which is acceptable. Within that limit, it's okay. I'm okay with errors. So errors is a natural thing. No device is perfect and we accept errors the way it is. But you should know how much uncertainty, how much tolerance, how much, degree of uncertainty is there in it. That is called as your error. Thank you guys so much. Yep, very good. Sir, the least count for a simple scale has 3 digits. Well, no, it depends on which units you are measuring it in, Ritesh. If it's in millimeters, then it's no decimal. But if it is in meters, then you will go to the 3rd decimal in SI units, Ritesh Jagan. So, example, let me put over here. Let's say I measure the time. How fast does Pandu run from this point to that point? I saw Pandu running from this point to this point, and let's say I measure the time to be 15 seconds. I'll put 15 seconds plus or minus 1 second. This is basically your error, and this error has come because of the least count of the device. This is basically your most probable value. So your time will be anywhere between 14 seconds and 16 seconds. I cannot tell you for sure whether it is 14.9, whether it is 15.7. I know it is within 14 seconds and 16 seconds. That's the range of values which I am tolerating. Is everybody understanding it? Pikachu, I think you asked the same question last lecture also. Yes, bacha, this is for both JEE as well as NEET. Yep. Okay. So, Joyce Mary, how about this? Why don't you leave a comment after the video ends? Maybe I'll help you out, or maybe towards the end of the class. Yep. Yes. But either ways, all the three versions are good. AI Live, Pro Lite, Pro Classic. It depends on what is your requirement. So it will be better if you leave a comment. Maybe I can discuss in detail or type in detail, so that others also can benefit from it. Okay. Same way when I measure the length, guys. Same way measure length or mass or anything else. I would say length using some scale. My height or my width or the object's length, I can just say it is, like 5 centimeters plus or minus 1 millimeter. This is again the least count of that particular scale. This is the most probable value. So you got a range of things. So this is your error. Now we can calculate error for certain devices. Some devices need to be used in a particular way, and that's how you can calculate the least count. Let's solve a question on that maybe. Look at this question. Hopefully you will be able to do it. No problem, Pikachu, no problem. But yes. Yes, Vishali, Pandu is always the best, and so is Champa. Yep. How can I get Tattva printed book separately? There is a, what do you say? There is a DLP course. So just leave a comment after the video and I can probably ping you the link of how you can get only Tattva subscription, hard copy separately. A spherometer has 100 equal divisions. What's a spherometer? It does not matter. You just have to look at it logically. And there is markings on the periphery of the disc. One full rotation of the disc advances the main scale by 0.01 centimeter. And the question is, what is the least count of a system? See, what it means is there is some kind of a scale. There are basically 100 markings on it. So this is 99. So you start with 0 and this is 1, 2, 3, 4, 5, 6, 7, 8 like that till 98, 99, 100. So there are 100 markings. 100 markings. If you rotate it by one complete rotation, then what happens? You move ahead. You move ahead by how much? You move ahead in the mean scale by 0.01 centimeter. That's one complete rotation. But one click, or I would say one division on this circular scale, on that circular scale, will advance you by not by 0.1 centimeter, it will be by 0.01 centimeter, it will be by 0.01 divided by 100, which is 10 to the power minus 4 centimeters. So 100 clicks advances by 0.01. So one click will advance by 10 to the power minus 4. That's the smallest amount I can move. Anything less than that, it's not allowed. One click is one division to the next division. So guys, what's the least count? It's going to be 10 to the power minus 4, isn't it? Yep, it is going to be option B. Very good. Yes, very good, very good, very good. Yep. Sir, will 1 come after many zeros in instantaneous? Please reply, because it is like 0.1 or 0.001 or point. I did not get your question. 1 comes after many zeros in instantaneous means? What do you mean by that? Yes, this is exactly like a screw gauge. Yes, in the last video with link also you can see. Definitely Joyce Mary, I think somebody had already asked it. So usually the least count is very obvious, but sometimes you might have to calculate it based on the given information. That is very, very logical. Now let's try to talk more about the errors in the readings. Sometimes maybe it's not because of the instrument, but because the manner in which you are measuring it. Like, I measure the current flowing in a wire, I measure it to be 26 amperes. I measure it using different device, it says something other amperes. Then somebody else comes and measure it, it is completely different. I use some other method, it shows something different. Sometimes you take repetitive readings. Haven't you done this? Haven't you done this? Sometimes you measure your weight and you're like, no, I'm not that heavy. So again you come out and then you do this, shake that weighing machine, you stand like this, you shake your body, and then again you stand. Now it's showing something else. But maybe I might have done some mistake. Again you come out, again shake it, and again just come and stand. Oh, now it's different. Oh, every time I got a different reading, I will take probably the average of the readings. Isn't that what you would have done? Exactly. Now, the same thing, you can do it for any measurement. Averages are known to improve the accuracy. And that's why if you have started practicals in your school or colleges, you will see always you will take multiple readings and you will end up taking the average. But remember, when you take average, it's not necessarily the correct value. It is not necessarily the final correct value. You are close to the correct value. It also introduces certain uncertainty. I don't know what's the exact value. You can always come to the closest value. You can reduce your uncertainties. Every time you measure a value, it is going to be fluctuating around that actual value that is supposed to be measured. So there will be some uncertainty in your final measurement. Let's try to understand it. All right. I hope this is clear. You guys, come on, go ahead, smash the like button. If the likes are less, go ahead, smash the like button in case you have not done that yet. You guys have to smash it. Come on, guys. Go ahead, do that. And if you're not yet a subscriber, you need to smash the subscribe button too. All right. Hello, Leah. Hello, everyone. Yep. My mainly weighing machines are. Yes, very true. Now, here is what we are going to do. See, imagine Pandu has to measure his weight. Example. So, Pandu measures his weight to be W1. Next time, he measures his weight to be W2. Next time, he measures his weight to be something else. And finally, he takes N number of readings. So, there are basically N, which is the number of readings that you have taken. Now what you do is you basically take the average of them. You take the average, so that is basically W's average. This triangular bracket often is used for symbolizing average. You can write WAVG, that's one way, or you can put triangular brackets. That means the same thing. It is nothing but W1 plus W2 plus Wn, the whole thing divided by n. So this is your average value, or sometimes it is also called as the mean. So mean or the average value of the weight or the reading. Great. Awesome. Thank you, Srinath. Now what you need to do is, this is the most likely value, but each value that you would have measured is probably different from the most probable value. Like this one is different from this one. This one will be different from this one. So if you take the difference, that will give you the absolute error, absolute difference or deviation from the most predicted or most likely value. So this value is different from this value by an amount of delta W1, which is basically how different is this value from this average value. From this average value. Same thing, this weight will have some error from the actual reading or the most likely reading by an amount W2 minus W, and so on and so forth. So delta Wn will be Wn minus the most likely value. Each value might be different by 0.1, 0.2, 0.7, 0.3, 0.1, whatever. You take the average of that, that will give you the average deviation. This is basically, these are all nothing but deviations. Deviation. Deviate means you want to do something but you end up doing something else. You want to study, you didn't study, you slept off. That is deviation. You want to study but you started dreaming. You want to study, you're looking out of the window. That is deviation. So deviation is what you are expecting minus what is actual. Actual minus what you get. So that is deviation of basically all the readings. What you can also do, you can get the average of all the deviations. Average of all the deviations, and this will be also called as the average or mean absolute deviation. Absolute deviation or error. So this will be nothing but take the modulus delta W1 plus delta W2 and so on and so forth. Take the modulus value, the whole thing divided by n. That will give you the average absolute deviation. I hope this is clear. Hope so, not there. Difficulty between NEET and JEE? Depends, Vacha. We'll have to see how things work out because things are very dicey as of now, Srinath. We do not know what's going to happen in the next few days. We'll do a question, don't worry. We're going to do a question. Having said this, let me tell you, let's say I take some readings. Let's say I take some random readings. Like I measure certain value to be 10. Then I measure the value to be, let's say for example, 12. And let's say then I measure the value to be, let's say for example, 8. Example. So the average value will be 10 plus 12 plus 8 divided by 3 readings. Correct, guys? So what will it be? This will be nothing but 30 by 3, which is just going to be 10. But if you take the deviations of each value, so 10 minus 10 is 0. Then again 10 minus 12, that's basically 2. Here 8 minus 10, that is going to be 2. Plus minus does not matter. I'm just taking the modulus values. So the modulus values are 2. So the average will be 0 plus 2 divided by 3. This will be nothing but 4 by 3. This is what is the average deviation. Average absolute average deviation. That's all. Great. Now what I can tell you is the final measurement, the final measured value always has to be written down as the most probable value, which is going to be like this one, in this case 10, plus or minus there is going to be some deviation. There is some degree of uncertainty. So plus or minus 4 by 3. That is how I'm going to leave it. That's all. That's it. I hope this is clear. So guys, then can I also say that this is also called as the absolute error? Absolute error. That's the absolute value. Absolute value in the error in that measurement. Absolute error. That's what you are going to get as the uncertainty. This is basically the uncertainty in that measurement. Everybody agrees with this? Everybody agrees with this? Great. Now, I want to define also two new terms. You will understand it very easily. Guys, if I tell you the length of a device or length of a table or length of an object is 10 centimeters plus or minus 0.1 centimeter, and the distance between two cities is 100 kilometers plus or minus 1 centimeter. Out of these two, which one do you think has bigger degree of uncertainty, more absolute error? Think about it. Yes, always error should be written for any measured values, always. Thank you, Indian girl. Which one, reading 1 or reading 2, which one has more absolute error? Obviously this one, the error, the uncertainty is 1 centimeter. Here the uncertainty is 0.1 centimeters. Now comes the question. I know this reading has more error than this one. But am I happy about second reading or the first reading? You guys put your hand on your heart and tell me. Will you be happy about second reading or first reading? Think carefully. This is like 1,000 kilometers plus or minus 1 centimeter. It's like from Jammu Kashmir to Kanyakumari. 1 centimeter error. Like, hey, it's okay, man. 1,000 kilometers. 1 centimeter here and there. It's okay. This 10 centimeters in that 0.1 centimeter. I will not be as happy as I am in the second reading. I would be not so happy about the first reading. So what are we talking about? Hello Prajwal, nice to see you back, bacha. So we are talking about the relative error. Relative error. So the first case, the relative error, that is what is important, is 0.1 divided by 10. 0.1 for every 10 centimeters. That is basically 10 to the power minus 2. You can also make it as percentage relative error by multiplying this by 100. So basically there is 1% error. 1% error, which is a big deal. You can try to calculate it for this guy. It's going to be in points, in decimals, which is why this is a better reading than the first one. Ganamadali, these are EMSAT 2023 classes only. Like for, you can watch the 11th and the 12th. There will be no special EMSAT classes theory wise because Newton's laws, errors, everything is the same like I've been telling before. Yes, mock tests, practice sessions will be there later on, but while you are studying, you will study for and prepare for JEE only. Very good. All right, is that clear? So we have learned about what is absolute error, like the actual value minus the expected value, what you are getting, and you can take the mean absolute value, that is you take the errors and take the average, and the final measurement will be the most probable value plus or minus the error in the reading. The relative error will be the error upon the most expected value. If you multiply it by 100, it becomes the percentage error. Percentage error. So for every 100, how much is the relative percentage? Like you all know. So this is what it is. Great. I think we should start solving some questions coming up on your screen. All right. Good evening, Aditya Purohit. Nice to see you, bacha. So what do we have over here? We have the mean time period of seconds pendulum is 2 seconds. And the mean absolute error in the time period is 0.05 seconds. To express maximum estimation of error, the time period should be accurately represented as. Little bit confusing, but let's see how many of you can do this. Hello Akansha, nice to see you, bacha. Hello Sakshi. Sir, this YT channel for class 11th? Yes, Aditya. This is for both class 11th and class 12th, bacha. And right now you're watching the Legend series, that's class 11th. There is Ultra Legend, that's for class 12th. And yes, you will be continuing this journey throughout for the next 2 years till you obviously get an amazing rank in your JEE or NEET 2024. All right, Anushri, crystal clear. Let's see, guys, how many of you can do this? The mean time period, so that means the average time period, comes out to be 2.00 seconds. And the mean absolute error, that means the average value of the absolute error, is given to be how much? 0.05 seconds. Hence, that time will be the most probable reading 2.00 plus or minus 0.05. Is that option there? Is that option there? Yes, it is there. But I have a question for you. I can see that this same value, although it is there here, but I can see this value over here and I can also see this value over here. Aren't they same? Come on guys, is 2 the same as 2.0 or is it the same as 2.00? Are they equal? Are they equal? Yes or no? Yes, mathematically they are equal, but physics measurement wise they are not equal. Like, my goodness, this is crazy, sir. What are you saying? Are you saying 2 is not equal to 2.0? Yes, measurement wise. Mathematically they are equal. Measurement wise they are not equal, because think about it. If somebody has made an effort for writing 2.0, if somebody made an effort to write 2.0, that means he was sure about the decimal. Else, you should be a fool to write that down. You should be careless to write that down. Right? So if you're writing 2.0, it means you are sure about that decimal because you have used an accurate device. If you have written 2.0000, that means you are sure till the second decimal. Maybe you have used a better device. So this is more accurate. This is more accurate. This is least accurate. Mathematically they are equal, but accuracy wise, error wise, they are not. So that's the reason why if this person made an effort to find it out till second decimal, it will be a slap on his face if you mark option A, because then you have completely ignored the second decimals. And here also, again, at least one slap because you missed the second decimal over here. Here you missed 2 decimals, so maybe you should get 2 slaps. I hope this is clear. Anshul, I belong to India, Vaise. Alright, by the way, I'm from Maharashtra but settled in Karnataka, and yeah, lots of places that I have stayed in across India. Is that clear, my dear warriors? Is that understood, clearo? So now you can tell, oh, now I know why I write those decimals. If I put that 0, it has some value because I have made an effort to find it out till those decimals. Okay, let's try to find out the next question's answer, guys. Here it is. The time period of oscillation of a simple pendulum in experiments is recorded as, so there is a Pandu. Look at Pandu's measurement, guys. I'm pretty sure you guys are also Pandus only. You will also record the measurements like this: 2.5, 2.6, 2.6, 2.7. Teacher will be like, my goodness, what kind of measurements are these? But anyways, that is fine. Human to err is human, right? So we are doing some error and we are human, so that's fine. So 2.6, 2.5, 2.6, 2.7. These are the 4 values. What is the time period of oscillation with error? We have to write the final value. Let's write down the values, guys, first. So I have 2.6, I have 2.5, I also have 2.6, and again I have 2.7. Come on, guys. What is the average value? What is the average value of that? What is the time period? All right. So what is the average value of that time? Come on, my warriors. 2.6 plus 2.5 plus 2.6 plus 2.7 divided by 4. Smash it and see what do you get. Crystal clear like diamond in your name, Legend Prachi. Will I complete both +1, +2 syllabus before NEET 2023? Yes, Anushri, definitely. But I will not complete the entire syllabus. I will be doing additional value-added services. You have value-added services, right? So I'll be doing value-added services in this batch because I have already done 11th and 12th detailed portion last year. I want you to watch that. In addition to those lectures, watch this, because if I repeat the same thing, then I won't be able to give you additional value. I won't be able to give you additional content, different kinds of problems. I want to do that to you. I want to improve your level, guys. Okay, that's the reason why I want to do it. 2.6, guys. 2.6, very good, very good. Now calculate the errors. So 2.6 minus 2.6, 0. These are the mod values, by the way. 2.5 minus 2.6, that is 0.1. 2.6 minus 2.6, 0. 2.7 minus 2.6, that's 0.1. These are the mod values. These are mod of the time periods. Okay. So what is the average of them? So delta T is average. What will it be? 0.1 plus 0.1, 0.1 plus 0.1 plus 0 plus 0 the whole thing divided by 4, guys. So 0.2 divided by 4, that is 0.1 divided by 2, that is 0.05. Hence, the time period, the time period measured value will be nothing but 2.6 plus or minus 0.05 seconds. That's the answer. Just check this out. Plus minus 0.2, no bacha, be careful. While plus minus 0.05, no? 0.1 plus 0.1 is 0.2 divided by 4. I think you forgot that 0.4. Oh, sorry, you forgot that 4. You have to find the average. This is average. You have to find the average. So do not forget that 4, else you will get a wrong answer. If they ask you percentage error, relative error, you know how to do it. It's fair enough. All right, simple. Everybody with me on this? Yes. So, oops, this is, I think, wrong over here. This value has to be corrected. Guys, thank you for putting it. I'll just probably correct it over here only. Yep. So this should have been 0.05 seconds. Yes, there it is. Now it's fine. Everybody with me on this? Very good, guys. Let's move on. Okay. So error of sum and difference. This is very important. This is crazy. This is very nice. Amazing way of adding, subtracting, multiplying, dividing, and so many other operations on errors. Imagine, for example, for an example, let's say 2 pandus, okay? 2 pandus. One pandu is here. Wow. And other pandu is standing on him. Other pandu is standing on him like this. Whoa. These 2 pandus are standing like this. Let's draw his mouth. I hope that is fine. I measure the bottom pandu's height using some device. And the pandu's height comes out to be, example, 100 centimeters plus or minus 2 centimeters. Some device I use plus or minus 2 centimeter. Everybody with me on this? Hello Dinesh, good evening bacha. Hello Saki, good evening. Now this pandu is standing on the top. This pandu's height, example is, let's say, 120 centimeters plus or minus 1 centimeter. Using some new device or new measuring method or whatever. Now if I ask you, what is their total height? What is their total height? What will your answer be? What will your answer be? Think logically. Pandu and Champa. Okay, where do you want the Champa to be? Shall we make this as Champa? Beautiful Champa. Oh, I think I need to provide lipstick also. Beautiful lipstick. See, beautiful lips. Wow, beautiful Champa. This is amazing. Okay, so that's Champa, that's Pandu. So what is the total height? Champa is standing on Pandu. My goodness. Thank you, Prachi. Yeah, looking very cute. Now I think it's become very cuter. So think this way, guys. Think this way. What is the max possible? What's the max possible height of Champa? 121. Max possible height of Pandu? 102. So max extreme, think about it. I will just write the extreme values. So here probably the minimum, here probably the maximum. Max value possible is 121. Here the max possible value is 102. So the total maximum value that is possible, is 223. Same way, the least value possible, 120 minus 1, that's 119. Here the least value possible is nothing but 98. The least value possible is nothing but 217. So do you see the range in between which they exist? So I think you got the idea now. So it is 120 plus 100, which is nothing but 220 centimeters, plus or minus 1 plus 2 is nothing but 3 centimeters. So whenever you have to add errors, so this is basically addition. This is basically addition of errors. You just add their most probable values and also their absolute errors. You are going to add them. Chala bagunna, TG Bharat. All right. Next case. Imagine. Okay. Next case. Imagine you had some maybe, I don't know, maybe some chocolates or some cocoa powder or some chocolate sauce or God knows what. So you had some nice chocolate sauce or nice chocolates somewhere over there, and maybe you had 50 grams of it with an accuracy or uncertainty, I would say, of plus minus 2 grams. From that, just like over here, I had added these two. Now I'm going to use subtraction. And in subtraction, what happens is I'm going to take away something. I'm going to scoop out something, and I'm taking out, let's say 20 grams plus or minus 3 grams. So the question is, what is remaining? Just like over here, I found out the total. What is remaining? What is remaining over here? Very interesting thing. See, when will the maximum amount be remaining? Think about it. When will the maximum amount be remaining? And think, when will the minimum amount be remaining? If actually there is 52 grams here and you take out 17 grams from a big number, oh my God, am I hungry? Maybe, yes. From a big number, you take out a small number. What is remaining is a large number, guys. What is remaining is a large number. Everybody agrees with this. No, I will come to whether it is 30 plus minus 5 or not. But do you agree, from a big number if I take out a small number? So what is remaining, guys? 52 minus 17. Is it not 35 over here? Okay, keep it as it is. Now, if very little is remaining, matlab means actually maybe there was less and you took out more. So that means you took out 23 grams. So now what is remaining, guys? From small, you took out a large number. So 48 minus 23. 48 minus 23, guys. Did you understand why I'm saying that? Everybody with me on this? Yep. So it will be basically 25 grams. Now I want you to think what has exactly happened. 50 and 20, 50 minus 20 is nothing but 30 grams. 30 gram plus 5 minus 5. My goodness, this has not subtracted, this has added. So this is also going to be plus minus 5 grams. So be it addition, be it subtraction. The errors always add. The minus sign is not applicable for errors. The minus sign or plus sign is only applicable for the most expected value. Isn't it a beautiful way of explaining this and understanding this? So whether it is addition or subtraction, the error is always going to be added, but the actual value will be added or subtracted depending on what operation you are doing. This is way you should learn it. Great. Now let's take up a question based on this. Let's see how many of you can do this. The length of a rod is this much and that of B is this much. Then B is how much longer than A? B is how much longer than A? Let's see how many of you can do this. Come on, my warriors. Think carefully and let me know in the chat box what do you think is the correct way of doing this question. If the length of a rod is this much and B is this much, how much is B longer than A? What's the correct answer for this? Obviously you have to take the difference. So B is 4.19 plus minus 0.01. This is for B. A's length is 3.25 plus minus 0.01. So basically I'm trying to do B minus A. What will this be? This will be plus minus. You will always add, guys. So this is going to be 0.02. And what's going to be here? 419 minus 325. Come on. What's going to be? Yep. It's going to be 0.94. 0.94. Yes, there we go. Awesome. There you go. 0.94. 0.02. Option C, guys. Excellent. Yes, Sunita, I think you missed that point. it was not 1, it is 0.94 plus minus 0.02. That's how you do this question. These kind of questions are very common. Now we'll go to errors, multiplication and division and everything else. So for example, let us say Pandu is made to run. Pandu is made to run. You want to calculate Pandu's speed. So Pandu's speed will be nothing but the distance that he travels by the time. Now the distance that you measure has some error. The time that you measure also has some error. So this S has some error, delta S. This time has some error, delta T. The question will be, what is the error in the velocity? Or maybe some other example. Let's say for example, kinetic energy we all know is half mass into velocity square. Let's say the mass has some error. Let's say the velocity also has some error. The question is to find the error in the kinetic energy. How much will this be? Or it could be any other problem like this, all right, where things are either divided, multiplied, or a combination of many things, square, so many things are possible. In those cases, what you need to do, the first step, okay, always express in powers. Express in powers. That's the first step. What you do? Express everything in powers of whatever you want to find the error of. Let's say I want to find the error of velocity. So here velocity is nothing but displacement raised to 1, time raised to minus 1. Everybody agrees with this? Is it that true? No, my mother tongue is not Telugu, but yeah, my paternal side is from Andhra Pradesh. Yeah, Andhra. Yeah, all right. Thank you, Arun, so much. I'm so glad. Guys, you can still watch my last year classes. Trust me, they are still good. It's not going to be absolute. I'm going to be just adding values to this. Newton's laws of motion maybe in few weeks. Okay. Okay, great. If you look over here, the kinetic energy will be half mass raised to 1, velocity raised to 2. Is that right? Everybody with me? Similarly, you can have some other quantity. I don't know, maybe something else, like some physical quantity is there. There is some constant, and P1 raised to 2 by P2 raised to 3, or maybe root of this. So then you can say that this P is that constant into P1 square into P2 raised to minus half. This is how you can write it. Express it in powers. That's the first step. Now the second step is basically the relative error. Relative error is the sum of the powers modulus value into relative error in each case. So this is very important. The net relative error is the sum of modulus of power into relative error in each of the quantity. What do I mean by that? Observe. The relative error in velocity will be equal to power. What is the power of displacement? 1. Modulus of 1 is 1 multiplied by relative error in the displacement. What is it? Delta S by S plus the next thing. What is it? Time. Time's power is -1. Always take the modulus. What is modulus of -1? It is 1 into error in time is delta T by T. That's it. Same way for kinetic energy. Observe, the relative error in kinetic energy will be, ignore the constants. Always get rid of the constants. Don't worry about the constants. Forget that. Mass. What is the power of mass? 1. Error in mass relatively delta m by m. Relative error in velocity will be 2 times delta v by v. That's how it works. Is that clear? This is the best way to solve the questions. Whenever multiplication, division, any random formula is there. Same way over here, the relative error in P will be C into 2 times, C is not there, my bad, sorry guys. Constant will never come. So the power of P1 is 2. So 2 times of delta P1 by P1. The power of P2 is half, negative, but negative should not be considered. So half into delta P2 by P2. This is the step. That's it. That's how you get it. And remember, always ignore the constants. I will just say over here only, Ignore the constants. Ignore constants. Ignore constants always. And this method will prove to be very effective for solving many questions, and you are going to see some application part of it right away. Okay, I've put it up in the slides also just in case. Let's start with a question. Let's say there is a physical quantity, depends on A, B, C and D. It could be anything. This is force, velocity, displacement, time, anything. The quantity which has lot of percentage error or brings in maximum contribution of error out of all the A, B, C, D terms is which one? Hello Abhishekar. Come on guys, let's see how many of you can do this. Very beautiful question. P is A cube, B raised to half, C raised to minus 4, D raised to 3 by 2. Let's see which warrior is able to solve this question within 20-30 seconds. Not more than that. You should not take more than that. The first step, always express it in powers. So it will be A raised to 3, B raised to half, C raised to 4, D raised to minus 3 by 2. That's the first step. Second step, the relative error in P will be 3 times, that's the power, delta A by A plus power of B is half, delta B by B plus 4 times delta C by C plus mod value of minus 3 by 2 is 3 by 2 times delta D by D. Now think carefully and tell me which of these terms is contributing the highest. Which of the terms is contributing the highest? If error in A is 1%, this will be 3%. If error in B is 1%, this will be 0.5%. If error in C is 1%, this will be 4%. If this has error of 1%, this will be 1.5%. So this has the max contribution like you can see. This has the least contribution like you can see. So whenever you change the value of C, the P value will get affected the most. And if you change the value of B, the value will be affected the least. Hence, the answer is C for correcto, C for captain. Shreyas, that's my Instagram handle as well. Welcome guys. Cool. Awesomeness. Moving on to another question. Wow, what do we have over here? So we have the time period of a pendulum. This is a pendulum. It oscillates like this, back and forth. There is a length of the pendulum and it depends on the acceleration due to gravity and the length, and that decides the time period. The length is 100, accuracy is 1 millimeter. Period is 2, the time of 100 oscillations by a watch is 0.1. What's the error in G? What's the error in G? Okay, let's try to think about this first. First of all, the time period is 2 pi under root of L by G, square both sides. So T square will be 4 pi square L by G, of course. Now I can take G on the top, so G will be equal to 4 pi square L by T square. So G will be nothing but 4 pi square L raised to 1 T raised to minus 2. This is nothing but your constant, and I have got G in terms of L and time because L and time are given. So I just played around with that formula. That's all guys, nothing else. Let's try to solve now. Let's see, do I know delta L and L? Observe, accuracy is 1 millimeter, length is 100 centimeters. So length is basically 100 centimeters plus or minus 1 millimeter. So basically delta L by L, because I'm going to need that, will be 1 millimeter by 100 centimeter. 1 millimeter is 1/10 of a centimeter, correct? 1/10 of a centimeter. So basically it is 0.1 centimeter by 100 centimeter. So basically delta L by L, shouldn't it be 10 to the power minus 3 guys? Shouldn't it be 10 to the power minus 3? Everybody with me on this? Great. Now let's talk about time, because length is done. Let's talk about time. I will need times error also. The period of oscillation is 2 seconds. That means the time period is 2 seconds. What about delta T? What about delta T? For that, look over here. This least count is 0.1 second. 100 oscillations. If you measure the total time, that 100 oscillations has an error of 0.1 seconds. It's not one oscillation. You measure 100 such oscillations, then you get an error of 0.1 second. So one oscillation will have how much error? It will be nothing but 0.1 seconds divided by 100, which is nothing but 10 to the power minus 3 seconds. See if this makes sense. This is basically 100 oscillations has an error of 0.1. So for one oscillation, this is all for one oscillation, right? So now if I ask you what is delta t by t, you will be like, yeah, it is 10 to the power minus 3 divided by 2, right? Everybody with me? Okay, some of you are saying, hope so, option A, I don't know, let's figure this out. Now going by this formula, G is some constant, this. So delta G by G will be equal to constant, never bother, 1 times delta L by L plus times power is minus 2, but don't bother about the minus sign, into delta T by T. So delta L by L is nothing but 10 to the power minus 3 plus 2 into delta T by T is 10 to the power minus 3 divided by 2. 2 cancels. So 10 to the power minus 3, 10 to the power minus 3, it will become 10 to the power minus 3 into 2. But that is just the relative error. Question is percentage. So percentage error in G will be 2 into 10 to the power minus 3 into 100. So that's going to make it as 0.2%. So 0.2%, that's option C, correcto. Great, option A is wrong, option C is correcto. There you go, that's how you're going to solve this question. So these are the kind of questions you can expect, not just in boards, but also in NEET as well as JEE. This is a beautiful question. This formula will be given, or later on you will learn about this formula. That's not the point. The point is how you are going to calculate the error in some quantity. Let's do one more question so that you will get some idea over this. Okay, ready? Everybody with me on this? Let's do one last question so that you have a holistic picture of how to do questions on errors and measurement. Let's do this. Here it is. The relative density of a material is found by weighing it in air and then in water. In air, this is the weight. In water, this is the weight. The relative density with percentage error. Now the formula for relative density is already given to you. We just have to make use of that. This quantity, you will learn it later on. You don't have to worry how did it come. You will learn that in the chapter of fluids. If you are a 12th standard student, you already know this. If you are a dropper student, you already know this. Else, you will learn that later on. Let's just use it. Just take it for granted. That's what we are supposed to do, because the concept is what is the error, not how did this formula come. Weight in the air, I think it is given. If the weight in the air is this much, if the weight in the air is already given, so this is done. Weight loss in water, that is not given, because weight in water is given. Weight in water is given. Weight loss is not given. So the weight loss in water will be actual weight, which was 5.00 plus minus 0.05 minus the weight in water, which is 4.00 plus minus 0.05. Interesting. Now this subtraction I have already taught you. 5 minus 4 is 1, so 1.00, that's standard. 0.05 will add, don't make it 0 guys. So plus minus 0.1. Everybody agrees with this? This is the weight loss in the water. That is also calculated now. Everybody with me on this? No, Krishna, it is not deleted. There are a lot of questions. On that. Good evening, Kushi. Nice to see you back, bacha. I'm guessing you're a little bit late, but hopefully you'll catch up later on. Now, relative density. If the relative density is denoted by R and W, weight in air, is this one, and weight loss is denoted by WL, this can be also written down as WA raised to 1 and into WL raised to minus 1. I have expressed it in powers, so the relative error in the relative density will be 1 times relative error in the weight in air plus 1 times this mod 1 minus 1 will be 1 relative error in the weight loss, of course. Now it's just a matter of substitution. I'm pretty sure you will get it now. See, delta R by R will be equal to weight's error in air in air, what is the error? 0.05. So 0.05 divided by the actual weight in air, which is 5. So that's the most probable reading, plus 1 times delta WL. Delta WL is weight losses error. So that is 0.1 divided by the weight loss most probable value, which is 1 itself. So guys, this is just going to be 10 to the power minus 2 plus 10 to the power minus 1. That's going to be 0.11. That's the error relatively, delta R by R, right? So the percentage relative densities error will be 0.11 multiplied by 100. Just check this out. So it should be basically 11%, if I'm not wrong. 11%, that's it. So that's the answer. So I can see 11% here. And yes, the most likely reading, the relative density, like I can see from here, weight in air is 5 and weight loss in water is 1. So that is basically 5. So hence it should be 5 plus or minus that 11%. That's where you get it. Plus or minus that 11%. Let's just check it out. Yes, that is the correct one. How did I get this? This is the most probable reading. Most probable reading is always the most probable values. You know, just substitute the most probable values. The weight in air is basically 5. Weight loss, I just calculated it. It was 1. That's how I got it. As simple as that. Hello, Ruben Akash. Everybody with me on this? So I have put some beautiful questions for you guys to solve, and I would love to see how many of you can solve this very quickly and leave a comment as soon as the video is over. I would be very happy to see that. And if you would love to join me in the JEE as well as the NEET courses, 2-year-long courses, just for 15,000 bucks, 15,000 bucks for JEE or NEET. Even the higher versions are just for 94,000 rupees. But these prices get discounted heavily the moment you use my coupon code, and the coupon code is basically SHHPRO. The moment you use this, you will see there will be heavy discount on all these courses, and in case any issues, you can always get in touch with me. So that's my personal coupon code which I'm giving to you for availing the best discounts on any course at Vedantu, and you will find all the amazing content, be it tests, be it assignments, be it anything, right? What you need for any coaching, but with the best teachers and personal curated material, JEE separate, NEET separate, English batch, and doubt solving, parent teacher meeting. You don't have to travel anywhere, and obviously affordable prices, not as expensive as the offline courses, of course. So that's it from my side today. I hope you guys had a great time. Maybe I can get you guys up on the screen. So just to say you guys bye-bye. I hope you guys enjoyed it. What have you covered till now in today's class, Bacha? So basically in today's class, what I have done is errors. That's all. Addition of errors, subtraction of errors, multiplication, division, and all of that. And also least count. That is what I have done in today's class. So how you operate on errors, what is an error, all of that. Okay. So these are value-added classes apart from the regular, playlist that you have, the nurture playlist. This is something which you should always go through. I will not repeat the same questions because I want to add something extra to your existing knowledge base. Okay. Is there any course for 1 year NEET? Yes, Bacha. You can, when you're watching this video only, if you go down below and if you click on this, let's say NEET, for example, you just click change over here and just select NEET 2023. So you select class 12. Right now it is class 11 science. You select class 12 science. You will get that. As simple as that. So that's how you get it. All right. So you have all the courses. Like you can see, when you use my coupon code, you can avail discounts. Okay. So you can see you have saved 7,000 rupees. My goodness. So that's how you save money. Great. Cool, guys. I will see you around again in the next few classes. I will do additional classes for basic maths, maybe vectors and relative motion and all of that in the days to come. Stay tuned. Make sure you have hit the subscribe button, and yeah, do not forget to smash the like button and drop the comments as soon as the video is over. Bye. Hasta la vista. Take care.